Well, good morning, everybody. Nice to meet everybody. My name's Chris. I'm one of the applications engineers here at 3D So as Jordan says, this isn't a typical thing for me, so if it's not as slick as you would expect, you're right. But typically my role includes using scanners on a daily basis. So within the company, whenever we do any kind of reverse engineering, that's typically one of the routes that we'll go down. We've typically got CAD where we've got the scanning. So we tend to do both. Some have its benefits over the others. So what we're going to cover today is typically how I use the scanner, what I use the scanner for, and then we'll go through some of the features of the scanner itself, do you a demonstration of a couple of different types of scans. So we'll do everything from a rapid scan through a laser scan. We'll do some, let's have a look. We'll go through some settings in terms of how we track the models. So we'll do some handheld tracking with no markers, then we'll put some markers on and we'll track the markers as well. So in terms of what we'll scan some industrial jigs, we'll scan some artwork, some bones, bits and pieces like that. So we've got a good range and give you a good idea of what you can and can't do. As you can see on screen, what I'm going to focus on is the new latest and the greatest. This is a piece of kit that I get to use on a daily basis. So you can imagine how lucky I am. So I've gone from using verniers quite a lot throughout the day to essentially using the scanner. So we can show all that off. I think as well what we'll do is we'll show off some of the color scanning as well. So you probably get a scan of one of my colleagues. We're going to try and squeeze that in as much as we can so we can cover off as much of the features as possible. If anybody does have any questions, by all means, pop that in the chat box. Jordan will make me aware and we can go through and we'll answer them one by one. But I'm going to try and squeeze as much information as I can in. Obviously, we can't cover everything in the space of an hour. So anybody, if you have any technical questions or any bits and pieces like that, then we can always arrange a one-to-one. We can go through and we can go through any of the details that we've not been able to cover in detail on this. By all means, just let Jordan know, and then we can make all the arrangements for a one-to-one meeting with anybody who needs it. Just bear with me a second, we've just got one of the arrivals coming in. Okay, so I've got two setups. I've got one that's running the scanner and one that's running the meeting. So I'm going to end up swapping between the two. You don't think I'm looking at you, it's essentially I'm looking at the other machine. So essentially what we have and what we're going to run through today is the Einscan HX, which is a blue LED and laser scanner, which gives us multiple options, gives us many features in terms of alignment. So we're going to go through that. And rather than me just discuss now and go through a spec sheet, which you could go through on the website yourselves, and essentially list off all the specs, I'm going to try and do that at the same time that I'm scanning so I can show you how a feature works rather than tell you that it's just got it and how they help me out on a daily basis with reverse engineering and getting 3D models and everything together. I've got nobody waiting, so we'll move forward and then if anybody else comes in, I'll just need to break off for a couple of seconds and let them in. So the Einscan HX, which is this model here, which is one of the handheld models. For me, a handheld model is much more useful than a fixed scan, just purely because of the number of applications that it will allow you to do. So we're not fixed. It will allow us to move around some large items, for instance. So typically where this technology's come from with a laser scanner is you'll have a fixed scanner in the center of the room, fire through a prism, and it will send all the marks off. Now that typically has a limited field of view. It is also limited to the plane and direction that the lasers are scanning, so we've got the X and the Y directions. So by having a portable scanner, it allows us to manipulate the scanner and move it wherever we want. So when I do the demonstration, you'll see I go into the parts that we're looking at from multiple directions. That also allows us then to scale up. So we don't just need to do desktop. We don't just need to do the kind of parts that I'm going to show you today. We can, for instance, if we wish, pull a car into the technical center, and it allows us then, with quite a long cable, to move around the car. So in terms of the field of view, you're going to be looking at a max field of view of 420, 440 millimeters. So what we're going to need to do is back off away from the model. So whenever you're doing a big scan and you want to back scan a car or something like that you need to move around, just need to make sure that you've got space on either side of the vehicle, so you've got the depth of field for you to do on the scanner. So when we go into the actual demonstration, what I'll show you is how far we need to be away and how we judge it and how we calibrate that. So what I think we'll do is if we move into the scanning, and I'll explain step by step what I'm doing, the workflow that I do, and how each of the features work. So as I scan, I'll go through and explain how fast we're picking things up, how many points we're picking up in that time scale, and how that will actually visualize on the screen and how we actually get the resolution and details into the model. So what I think we'll do first, as you can see on screen, I've got two options with the HX to start. I have a rapid scan and a laser scan. So rapid scan, handheld, on the bench, fine detail. Laser scan will just allow us to add a little bit more to it. So dependent on the application. So for instance, at the moment, what I'm thinking in terms of a rapid scan is we have a lot of customers that are from museums, artworks, bits and pieces like that. So for a handheld rapid scan, we do something particularly like this, for instance, which is a replica of a dinosaur skull. So typically, the reason why we would scan this is it's almost impossible to replicate it through CAD. Very difficult. There's a lot of complex curves. Trying to measure that and actually map that out and draw it by hand in CAD is incredibly difficult, even near on impossible. So that's where I would use a scanner like this. That's my first thought process when I come to an application. Is the CAD going to be lengthy, take a lot of time, take a lot of money? Is it possible? So then that leads me on to the scan. Scanners.
Sorry, Chris, to interrupt you quickly there, mate. We just got Shining 3D waiting in the lobby. Sorry to interrupt there, mate.
It's all right.
Thank you.
Right, Gabrielle is in. Okay, so as I was mentioning before, it's typically the application which leads the type of scan that we're going to do. So this one, for instance, what we're going to do is we're going to do a feature alignment. So the scanner will pick up on a feature and it'll align itself when we move around the model via its features. So we don't need to put any spots, marks, anything like that on it. So if we just go ahead with that, so I'm just going to end up stepping to one side. We'll go on to that. Okay, hopefully everybody can see that. I'll just double check. Perfect. Okay, so with every scanner that you purchase, the appropriate software comes with it. So the software that I show you today comes in with the actual scanner itself. So this particular software is the Einscan HX. Throughout the range, you have slightly different softwares, which is directly related to the scanner that you buy. There are engineering packages, there's reverse engineering packages, and different bundles of software and accessories that will come with the scanner. I'll go over a couple of them at the end, and then in terms of your applications, your industrial, the industry that you're in, we can go over just what features and what added softwares are available. Once we've got some data together and you see what the scanners can do, we can show you then what we do with the data and what potential bundle you may want to purchase when you buy the actual scanner itself, so you're covered on everything. So what we'll do first of all on this is just create our new project. This is just all by the by admin stuff whenever you get a scanner. So essentially what we're doing is just telling it where we want to save all of our information. And now we have all of our options. So what we're going to do here is we're going to do a non-textured scan. You see that on the left-hand side. We're going to align it using the model's features itself. And you can see there we have multiple options. So we've got markers and hybrid alignment. So if we stick with this one for now, I'll show you a non-textured features with medium detail. We can go high detail, but it'll probably just slow us down and you'll end up waiting just while we process some data. So if we keep it for now medium data, we'll show you the features. The next scan I'm going to do is we will look at aligning with markers. And so then we can show you the differences in the models and when you would apply markers and when really there isn't any need to. Okay, so if we apply that, we've set our settings. Next thing then we're going to do is we're going to start a preview with the scanner. So very straightforward. We've seen there just when we turn the software on, we're within 60 seconds of turning everything on, we can pretty much start to scan. So on the scanner itself, we have all the features available on the back here. Now, I'm going to talk about certain features, and you won't be able to see them, but essentially here, I have all the controls that I need, so I can control it via laptop, or I can control it via on the back of the scanner itself. Now, when we're in the preview, what it's showing me is just essentially that we're there. Now, if you have a look on the left-hand side of the screen, I have some distance markers here. So that essentially tells me that I'm green and I'm in the right distance away from the model itself. Now, throughout the scan, what I'm looking to do is keep that in that point there. So I don't actually have to have a look at the screen because fortunately, on the back of the actual, we have LEDs. So on the side there, as you can see at the moment, they're red because I'm too close. I can watch that on the back of there. So you don't necessarily have to have the laptop screen right by the side of you. So when we do the preview, we can see the model, we know everything's working. So all we do is we've got a play button on the back, hit play, there we go, and then we start scanning. So as you can see, we can see the skull that I showed you a second ago. And as we move around, all I'm looking to do is keep that left hand in the green mark. And essentially there, I can see that on the back. Now, what we're going to do is I'm going to try and trip it up. You can see there at the bottom, it says tracking lost. So this is the feature that I'm discussing in the settings that we've set up. So what it's doing is it's looking for the features of the model. Now, as long as everything isn't exactly symmetrical, and as long as everything has a little bit of randomness to it, it can check and it knows exactly where it's featured on the model. So you see where there, we've moved it too fast, I've not scanned that side, and we've lost the tracking. And it's come back again now. So what it's doing is it's focusing on the model, it's doing the scan, and as it's making those nodes and the mesh, each triangle then is unique. Because everything's quite random, it's not symmetrical, it allows us then to use the alignment feature of the actual scanner so we don't have to put anything on the surface of the model. It will purely track it just by its features itself. Now, if this was completely symmetrical and both sides were identical, it would have a bit of an issue when we swap around to one side. So that's where we would bring in our markers, which we're going to do on the next scan. So we'll complete this one, and then we'll talk about the markers and how we use them and how we lay them out. And you'll get a bit more of an idea of the differences between the two. So if we move around, I'm just moving in and out, trying to get the data. So what we can do, and a useful feature, is I've laid this down on a bench, and you can see right underneath the actual model, I'll just point with the cursor, you see around there where everything's kind of black, and then we seem to have some noise all around the side. That's essentially everything else on the desk that I'm picking up. It's the desk surface. And the only reason why that's coming up black is I've got the model actually on a black surface there. It's just a black mat that we're picking up on. So what we'll do is once we've gone through and we've picked up some of the data, we'll go around the model once. We can then pause, and then we can start to get rid of some of that noise and just make things a little bit easier on ourselves. So we've got the right distance there, and it's just following the details around, and it's using the model's own actual features to track. So see how we've lost there? We've just got a few features. So essentially what I need to do is just put a little bit more detail and move the scanner about. So with the handheld feature that I talked about before, the difference between a static scanner is I can go all the way above the model, don't need to move it, and I can scan. So where we've got there, we've got not enough features to align. So essentially I've swapped from doing one side directly onto the top, and now it doesn't know where it is. We come over to one side, get the model back, see there, now it's picked it back up again. We'll just slowly go up that side and get those features all the way back in again. There we go. So it's scanned all those. So what I think we'll do is if we pause that now, we'll get rid of some of that noise and make it easier on ourselves. So that's our first point of our scan. So what we're going to do is just edit quickly. It's a really simple tool here which will give us a circle. It's essentially a lasso. And what I'm going to do is select my model. So if I lasso around that, don't worry about being completely even because the scan data is going to pick it back up. What I want to do is just revert, tell it that that's what I want to keep. We can get rid of the rest, and then we can just get rid of a little bit more. Delete. another one. Just rotate them all around. So what we're going to do there is just get rid of that that's quite close to the model. So spin it around. Get rid of that. A little bit more. Okay, so there we have now a lot less noise. We know exactly what we're dealing with, and then we can see the features that it's picked up, and we can see where we just need to concentrate on the model, fill a few other pieces in, particularly there, the left side of the face, the jowls, and so on. So all we need to do is pick the scanner back up again. You don't need to do anything on the laptop. We just hit the play button on the back, and that will give us a preview mode again. Okay, so we're in preview, we pick the model up, and we just hit play, and we go straight back to scanning. So what it's doing now is it's going to find its tracking again from its features. So we're at a good distance. So there, we've picked the model up, and we'll just go around slowly, make sure we get all the bits and pieces that we need, that we just saw when we edited and got rid of some of the noise. Now, the handy thing with this is I can move the scanner, I can move the model. So then what we're going to do, if you notice we've got it on a desk, to get the whole model so that we can get a watertight model that we can then reproduce and print, we're going to flip it over and we're going to do the underside. So with this focus, we'll get these three surfaces all in place. And then the next thing that we'll do is we'll pause, get rid of some noise, and then we'll flip it over and we'll go into more detail and essentially try and get ourselves a nice watertight mesh. Flip that around, you can see all the features now starting to come in. Now, we do have some quite tight little holes and features. So this is where having a handheld scanner is really quite useful versus a static one that's on a tripod or something like that. So you can see there, I can move around the model and I can actually focus on the areas that I need to, get in underneath, and go right down to the bench, get all the features in that we need. You see there, it's tracking all the way around. Now all I'm doing sometimes to help myself is just spinning the model around on the mat that we've placed it on. Just on that back bit, it does seem to get a little bit geometrically simple, so it can sometimes lose the tracking. There we go, pick that up again. Now, let's go around to the other side. There we go, and that's picked that up. Okay, so we've done another few passes, so we've got a lot more cloud data there to work on. So if we pause there, and we'll have a look at how good we've done. So we go back to the editor. You see there, we've picked that noise back up again. We've got a lot more features back in the model now by doing that second pass. So what we'll do is we'll just get rid of that noise again, and then we'll preview and see what we've got. So we'll get our lasso tool, start deleting, zoom out. Okay, so the quickest and easiest way is we'll just select the model, tell it we want to keep it, and get rid of the rest. Okay, so there we are. What we can do now, do a quick point, and we'll finish our edit. And then we can, if you want, we can generate the point cloud. So it's going to process all the information there that we've just put through, and then we're going to have a right good look, see what we've got, and then we can see in the actual, from the cloud point data, what we need to fix, any particular features that we need to focus on with a little bit more detail. So that can take some processing time. So while that's doing that, we just discuss the features of what we've gone through. So with that particular scan that we've just done, when we've done it handheld and we've done a rapid scan, the accuracy is up to 0.04 millimeters, The volumetric accuracy is 0.04 point through to 0.06, and it's done it in about 55 frames per second. So we're collecting every single second around about 55 frames, and every single pass that we do, we're adding to the amount of data that we've got. So let's have a look what we've got. So as you can see there, we're starting to get a really detailed scan, and it's really not taken that long. But what we do see is we've just got a few bits that we need to fill in, and as you can see there, when we've done the scan, we've created a surface mesh. So in terms of a CAD perspective, what we've done is we've made an infinitely small mesh that shows us the surface model that we need to do. So to make that into the skull here that we're looking at, as you can see, we've got features underneath. So what we're going to do is we're going to get the model, we're going to use that alignment tool that comes with it, and use the features to align it. So what we're going to do is we're just going to flip it onto its side. We'll scan one side and then gradually rotate around. Where I did the sides before and I rotated over the top, we're going to do exactly the same again. We're going to flip it up the other way so we can get the undersurface in. Once we've got that undersurface in, essentially then what we can do is, 1 second, I've just got somebody to admit.
It might just be the chat box, Chris.
Just the chat box, right.
Yeah, it's the chat box, dude, don't worry.
Right, okay, we'll go back to what we're doing. So what we're going to do next is we're going to try and fill in all that area there, so then we actually make a complete model rather than just the outer surface that we've got from those 3 sides that we've already scanned. So what we do is we generate 5-point data, we know what we need to focus on. So we're going to set up. Quick hit of the play button puts us straight back into preview mode. You can see that the model's scanning. So what we're going to do is we're going to lay that down now on its side. We know we've got those features, so it can align from that. So we can get the scanner, hit play, get the right distance that we need. There we go. So what it needs to do now is just find those features that we've scanned. And then we'll be able to get the undersurface in. Just wait for it to find itself. Okay, so we found it there. We've got the features that it already knows, so it's recognized those. And then we're going to slowly keep track of those features and then just rotate the model around. So then we get a full 360-degree view of the model that we're scanning. So you can see there, without any markers or changing the surface of your model, we managed to track all the way around, and it's now scanning the undersurface. So now we're creating a full 3D model, and then it's going to give us the data where we can then mesh everything together from the cloud points, and then we can tell it to make a watertight model. So just rotate around, getting all the features that we need. So as you can see there, everything that's highlighted with green is it fully recognizes, it scanned the data, and it's created the nodes and the connections to create the mesh that we need. What I'm looking at is all the areas that it's not highlighting in green is where I need to focus and essentially get rid of any of the missing data, the bits and pieces that we need. So we see there, we'll just track around the back. And to give it a chance, then what we'll do is exactly the same, but we'll go from the other side. So then we get the undersurfaces in as well. So if we flip that back towards us, you see we'll go for the other side. So it's lost its tracking and found it again. So we do exactly the same thing again, and we just slowly rotate the model so that now we can see every angle, and we can start to get into all those features that it couldn't do before. This is the joy of handheld, is I can get everywhere that I need to. So we can see there, we're getting right into its mouth on the underside of all the teeth. And just bring it back a bit, I'm just a little bit too close. There we go, picked it up. Just rotate it around. And then now we've had it on its side and we've got those features in, I'll just pop it on the back. So now, get tracking, pick up, and now we're scanning the exact opposite direction that we were before. Should have all the information down in. Okay. So if we pause and edit that, I'll get the cloud data running again. And then we'll see the results that we have. So just quickly back to the edit. Again, let's get rid of what we don't need. Zoom out a little bit. So we've gone through a lot more direction here. So you can see we've got a lot more noise. We've just got to pick the model out of all that and then choose to keep it. So let's go around. Much easier to deal with now. Get rid of that. Okay, so that's looking much better. But tidy up. Okay, and then what we want to do is finish our edit. And we can see what we've got. Now, once we edit the mesh data, we'll see how smooth of a model that we've got. So we will generate 5 points. So we'll put that. Okay, while that's generating, again, rather than it being quiet, I think on this what we'll cover is, with the scanner itself, you'll see shortly we go on to a marker tracking system, so we're going to track some markers. We can also do a colour tracking system. So what I think we'll do is we'll finish up on the skull, we'll show you the data that we've got. We'll then show you how it tracks using markers, and then we have a feature where we can track by colour as well. So that could be anything with multiple colours on, it will track. We've had anything from a chair, for instance. That's quite generic in terms of its geometry. And the colours on the chair itself allows us then to track the actual data points. That works really well. And I think what we'll do to show that off is I'll get a colleague in, and if we scan then, you can see how the colour comes through. And it'll track from the colour features on there as well. So there are multiple options that are available. So we've done the first one, which is just from its data. You can see there how smooth of a model that we've got, and we've got all those complex curves in that we need. So essentially what we would do there then is mesh that model and essentially create the mesh. And we can watertight it, we can do a medium quality. And if we apply that, you'll see then what it'll do is it's like a fisherman fixing his net. So a mesh is essentially nodes and connections, it's typically polygons. And what it'll do is anywhere where we've missed and we have a hole in that model, it will stitch all that together for us. It's quite random. It will do its best. It doesn't know this is a T-Rex skull. It will essentially follow closely the geometry that it's already formed and form a similar curve. Now, all that could be edited later on in CAD software. You can see there the level of accuracy and the data that we've got in such a short time. Now, if I was to even try and CAD that, I'd still be here till next year. So again, it's a great feature, really quick scan, and it's given us a really, really accurate model. So in terms of what we discussed before with the accuracy, is we're down to a volumetric acid of 0.05 millimeters. So it's about 50 microns, really quite accurate. And the points that it's actually looking at when we do that scan, with the HX model in rapid scan, we're looking at about 1.2 million points that it picks up pretty much per minute. So it's a really quick frame rate and can create huge amounts of data. So there we've got a really, really smooth model from a rapid scan. If you want more detail, what you can essentially do is keep passing over the model. Every single time that we pass over the model, we're just creating more data points, more nodes, more connection points. The more information that we've got, it's going to give us a better file. What that does then is it will give you a file that takes longer to process. And you see there with a rapid scan, the processing takes less than a minute. If we were to add, we could add, and we keep scanning, keep scanning, keep scanning. We're just going to make it bigger a file, so that essentially the processing time goes up. So it's a case of how much detail that you want. It's a little bit of a compromise. Every single time that we have data, we're just adding time into your workflow in terms of processing down the line. But you can see there with the under 60 seconds, the kind of the level that we've got and the detail. So that's a fixed, essentially a rapid scan. What we'll do next is we'll go onto a laser scan, so we can show you some more added details, and we'll use a different feature in terms of tracking. So we'll go from tracking from the geometry, and we'll track using some markers. The markers will come with the scanners themselves. So what we'll do is we'll just get rid of this scan, and then we can start again, and we'll move into a different one. So 1 second. Apply that a little bit. Okay, so finished on that one. So we'll just restart. And we'll start a new one. Hang on a second, and then we'll just get that straight back up for you. Okay, and then we're back to the beginning. So now what we're going to do is we'll set up a laser scan. So on the scanner itself, we've got two options. We've got the blue LEDs and we've got lasers. So it's essentially now working as a hybrid. We're using both systems. So essentially what we're doing is we're looking at the blue LEDs and it's measuring the distance with the time that it takes to bounce back to the sensor. Same with the laser, but the laser allows us to have a little bit more accuracy. Just like before, we just set up a new project, use the default folder. Okay, so with this one, essentially what we've got is, again, high detail, medium detail, low detail. If we go for medium, it just means we can process it all while everybody's on here, and we're not waiting a little bit for that. Click apply. Okay, so we've got a few more settings over here. So we've got scan the point cloud, we've got objects, and we can tell you whether it's reflective, it's black, and then we've got the scan markers, and we can adjust the brightness. Now in terms of features, what we said with this one is if we do a marker scan, so if we turn that on, I'll show you the object that we're going to scan. So essentially here, we've just got a jig, it's an industrial jig, and we've got some features on there. Now, with it being geometrically pretty similar, it may struggle to see there, it's essentially symmetrical, so it may struggle to follow it and track it just by its features alone. So all we've done is the pack comes with reflective stickers that are built to go with the scanner. So it notices, and it notices the brightness, and it knows then that that's a scanning point. So my mistake when I first started with scanning is, because I have a background where accuracy is key, I went and put on stickers on, and I put them on as uniformly as I possibly could, which completely defeats the object. What we want to do is just randomly stick them all over. And then essentially what it's doing is it will make a triangle between those three, and that is unique. So it's the distance between all three marks, and it can recognize that instantly, and then that's how it's actually going to track the model itself. And that's how it ties everything together. So we could go everything, we could turn it around every single different angle, and it'll know where it is because it knows where these tracker markers are. So you'll see those when we actually start the scan. You'll see those pop up on the screen. We'll put it back on our black mat. Now, you'll see underneath here where we've got our objects. So essentially what we're doing is we're telling it what our surface is like. So we've got a pretty normal surface. It's a 3D print. It's in gold, so it's quite shiny, but it's not massively reflective. The reason why that is important is because we're dealing with a laser and we're dealing with light, and we're looking at how quickly it bounces back from the object itself. So typically, if it's overly reflective, what can happen is the white balance can overexpose, and the sensor doesn't pick up on the surface. So we just need to tell it that that is the case. If we do have something that is particularly reflective or lacking in any sort of reflective material, so black, for instance, will absorb a lot of the light, which is why we tell it that it's a black surface. So there's options available, multiple different ways around that. We found a really good one is a scanning spray. So this essentially we can spray on any model, and it will evaporate and disappear within the space of about 2.5 to 3 hours. So then that will give us a white surface that's non-reflective, which just gives the scanner a better chance, essentially. So that's always an option. So if we just set our settings here, then we've got a normal surface, we've got typical brightness. Now I could adjust that brightness. Here we're in a technical center, we've got natural light, we've got LED light, and as you can see from our previous scan, that hasn't interfered. If you're in a particularly bright environment, that's going to change the light source that bounces out from the scanner and bounces back, and that could essentially create interference. So that's where we can adjust the brightness, very much like a camera. What we don't want to do is under or overexpose. Essentially, that's lost information. Okay, so if we then start the preview, what we want to show is just where we have our markers, and then we'll see how the markers get picked up. So exactly like before, just on the back of the scanner, what we do is we want to hit play, and we've got preview. And you can see straight away there, it's recognized our markers and knows exactly where they are. And I can spin the entire model around. You can see my other markers will pop up. So we're happy with the brightness, everything's going to work there. So what we'll do is we'll hit play, start to scan, and see where we are. So all we've got to do is just get the distance right on the left-hand side, and there we are. It's picking up now on those spots. It goes up, so it's going to rise. Pause. I'll just reset this, because essentially we're just picking up the scanning markers. I'll just reset, 1 second. Yeah, I can't see that on here. 1 second. I've got the sharing thing in the way. So, okay, so just go back and just reset. So we've got our markers, switch the laser scan. Same settings. Good preview. Let's make sure we're picking everything up. Okay, so there we go. You can see the difference. Now we have the lasers on. Essentially, we are projecting a grid over the entire object. that's where it's going to allow us to get that extra data and the extra data from the scanner itself. So you see there on the preview, all of our laser lines are scanning and we're picking up on the laser marks. And started moving the right distance. And we'll start to rotate and you'll see we'll start to pick up those features. Again, same thing. Now all I'm doing here, just to make it easier on ourselves when I'm still in the camera, is I'm just rotating the map that I've got the object on. Now, throughout the range of 3D scanners from Einscan, we do have turntables and accessories that are available. So all throughout the range from the Pro 2 all the way through to the HX, sorry, the Pro 2 Plus, is tripods and the turntable, so we can do a fixed scan. So essentially what I'm doing here is holding the scanner still and rotating the model just to make it easy on myself. That's a feature that comes available on the older models throughout the range. With this one, you could do exactly the same thing if you wished. It just allows you then at the same point to move things around by hand and manipulate how you wish. So with this, essentially what I would be manipulating, now that we've got a good scan there, it's just being able to move and just focus on some of the features like the holes and bits and pieces. I just want to focus on those so we actually pick those up. So you can see there we've picked up the two holes on the front, picked up the holes on the side, just move a little bit further away. And then we pick that up. So now that we've got some data and it knows where its marker points are, I'm just going to quickly just go across the top. And again, this is the benefit of handheld. As long as we go slow enough, we'll be able to see there. Lost it 1 second. And go back again. We just need to move over the top. Distance away. Okay, so I'm green everywhere. What I'm going to do is just pause and then we'll see what we've got. And we'll get rid of a lot of that noise. So what we'll do is just quickly lasso our model. That's what we want to keep. So, and you'll see there, we've deleted some of the model. That'll come back in the next pass. Just do another lasso. So, find that area. Okay. See there, we've got the actual markers, which needs to put the surface back in. So straight back to the scanner, play, preview. Distance. Okay, we just get that section straight back in again. Concentrate on those features there. Just turn it around. Okay, that's looking really good. So what we'll do next is we need to get the bottom surface on, which is sat on the desk. So if we do a quick pause, what I'll then do is just flip the model over. Put it on its side. And then we'll go again. Now, we've completely orientated the model differently. So what we're going to do is it just needs to then pick up on the markers, and it will find, recognize those. And then it's going to allow us to go around then we can get all the surfaces in that we couldn't before because where it was sat on the desk. You can see there what we've done is we've just stitched that bottom surface together. So essentially where we had all four sides, let's then scan the data in for the bottom surface that you can see before. So spin that around. That's looking really quite good. So what we'll do, if we pause there, we'll do an edit, get rid of the noise, we'll generate the file point, and then we'll show you what mesh that we get from that. So you can see there, as we change the orientation, you can see we've got a lot more three-dimensional noise. Hopefully my lasso skills are up to scratch. So there we go. Without that, delete. And then we'll just get rid of that side. Okay, so that's a lot tidier. One more. So we're just left with our model now. So if we finish editing, we'll check it and we'll see what we've got. Generate PowerPoints. Now this is always a good time. This is where we can talk about the bundles that are available. So the bundles that are available pretty much is all the same hardware. So a HX bundle, you always get the HX, you'll get the base software that I'm showing to you now. There are reverse engineering softwares available. So for an application like this jig, for instance, one of the features that you always get with a laser or a light scanner is we have some features that are pretty well hidden from a light scanner. So I can shine it down there, but as you can see, the holes go straight through. We're going to get bits and pieces that the surface isn't going to reflect the light back to the scanner. So this is where the reverse engineering bundle comes in, and it comes with a piece of software called GeoMagic. And what that'll allow you to do, and I'll show you on the mesh, as you can see here, we don't have the internal features. So if we have internal features that we need to get through, that's where you want the reverse engineering bundle. That's where the extra piece of software that comes in is ideal. Because essentially what you can then do is tell it that I have that diameter, and that diameter then transfers through the model. And we keep the same diameter all the way through. And it's essentially where we in CAD, we essentially tell it at the very beginning, and we start to put the dimensions on. So this is this is that, and we're locking those features in. GeoMagic will allow you to do that. So we'll have a look at what we've got. And then if we create the mesh, so what it's doing now, as you can see, where we've had the markers, it doesn't have any surface information, but it knows it's a marker, it recognizes that it's a marker, and essentially it'll fill all that in for us. So anything you put on the surface, with a lot of the older scanners and a lot of the fixed scanners that are just lasers with a prism, any marker that you put on the actual surface will come out on the actual texture of the model itself. See on this one, work out really well. Go medium, and we've got there mark hole filling. So if we put blank, let's see what it gives us, and let's see how well we've done. Okay, so you can see there the meshing data has taken a little bit longer with this scan than it has done with the rapid scan, just purely because we've taken a lot more information from the model itself. And you can see there we've got the model in, and we're looking pretty good. Now it's made that watertight, so essentially there, so we've got some features that we could potentially go again. So essentially there, what we can do, if we wish, is we could go back to scan and we can add more data, and essentially you can see there what we've got. So we could fix all the holes and bits and pieces with the reverse engineering. So you can see there, essentially, when we've made a watertight model, perfect for 3D printing, but we've lost some features, and essentially it stitched all those together itself, because it doesn't know. So that's where the reverse engineering bundle will come in. We use geomagics, and we essentially dictate and tell it that has a specific diameter, we tell it its direction, and then it knows that's a hole that's traveling all the way through. Okay. Oh, okay. Right, so that's shown off a laser scan, and we've shown off the feature of how it tracks a model using the markers. So what I think we'll do now is we can show off a feature of where it can track from colour, for instance. So we've gone through, we've done something that you couldn't cut up. It would be absolutely impossible. We've done something which is really quite detailed. So we've used some tracking markers on there. So that would be jigs, fixtures, sprockets, anything in the industrial sense where you need really high resolution and detail. So I think what we'll do now is, if I get one of my colleagues in, we can show you another unusual feature is we can scan individuals, we can scan people. So there's medical industries that are using the scanners. We've had people recently scanning feet, for instance, orthopedics, so that they can make custom insoles for people, bits and pieces like that. So there's multiple different applications for this throughout. Everything from art, even just, we have a lot of customers recently want to do scans on products, so that on your website you can have a 3D model that's rotatable and available. I'll give you an idea of how that works at the end of the session. Einscan have some great kind of case studies on their website of where the scanners have been used for the applications, and they've teamed up with Sketchfab for hosting 3D files. So we have a lot of people now interested in making a virtual warehouse of parts. So whenever you go on the website, all your parts could then be in a 3D model in color on the website. So this is a good idea of that. If I go back, reset the scanner, what I'll do, I'll get a colleague in and I'll show you how we can do some color tracking as well. Once we've done that, we've shown pretty much a lot of the features of the scanner and how they work, and you've seen them work in front of you. We'll go then into the range and what's available on the accessories, and then particularly the software and how the hot software helps and what bundles you'll want depending on the industry and what you want to do with the scanner. So we'll just go back. So essentially we just need to revert. We'll go back to our scan. That will essentially delete everything that we've got. Okay, and I'll just get that all set up for a scan, and we're going to do color features on this one. Just bear with me a minute, I'll just get that set up. Okay, so for the color tracking and for scanning a person, we're going to rapid scan. New project group, exactly the same. For and now what we're going to do is we're going to do texture. And we're going to align it from features, and it's going to do that in color for us. We'll stick with medium detail. If we go any higher, you'll end up watching processing, and I'm sure it'll pour you to that. So if we click apply on there, setting up our project, and now I'll introduce you to a colleague. His name's Chris. He wants to confuse everybody. We like to hire people with all the same names. But if you're a Chris and you want a job, give us a shout. Okay, so now what we're going to do is we're going to scan, and we're doing our, essentially, our detection and our tracking, we're doing from texture and we're doing from color. So say hello to Chris. Okay, so when we turn the preview on, he's there and he's very, very green. He's not that angry, don't worry. Okay, so our brightness is good, everything's working, and he's happy, smiling. You can see there in the top left corner, that's the camera view. That's coming from the bottom camera on the scanner. So, one of the good features about this, having been scanned before myself, is now they've swapped from the white LEDs to the blue LEDs, you can actually see Chris can pretty much keep his eyes open. Previously, you couldn't. I mean, I had to scan myself, and it was the white light. You can't possibly keep your eyes open. It's very bright. So you end up with a screwed up face. It doesn't work particularly well. This is just like you're being pulled over by the police with the blue light. So once we're on preview, we hit play, then we're going to start scanning Chris. And then what I'm going to do is use the length of the cable. I'm just going to walk around, looking at the back of the scanner, I'm just keeping the LEDs in green. Very, very easy. Walk around, and the scanner itself there. What we've done there is we've lost a lot of texture and we've lost a lot of colour where we move through to the back.
You're a little bit quiet back there, Chris. You have to speak up a little bit, mate, when you're further away.
Okay, so what we do is with the handheld, we're going to move all the way around and we're going to get as much of the 360 on Chris as we can. So there we go, let's put it back up again. So we're just slowly move around, let it keep tracking. Keep counting, filing, can't really let them down. Okay, so we've got tracking picked back up there. Down. We come all the way back down to the other side. And go up. As much as we can. Now, Chris has dark and hair. Do the pitch quickly. We'll not play any white. I want to do a big one. You'll see how much of his hair you can actually get. The detail very good, so you can pick up hair in general. Need to, what we'll do, if you struggle with the black and the black and hair, we'll change the brightness and get that twisted. Now, one of the cool features about that is I don't necessarily have to go all the way back to the laptop. We can do it here on the scan itself. Give me 1 second. So, look. All we're going to do, see there, it's using the colour and the texture, and that's what it's using to track. So you're getting a little bit more tracking in here. Okay, brightness. Right now. A little bit more information feeding back into the scanner. Essentially what's happening there is where this dark hair is absorbing that bright blue LED light. As we've turned the brightness up, it's picking up more information as it's bouncing back. Keep my eye on the tracking. Go back. There we go, so it's picked up from there, and we can do the same as we did on the other side. Slowly getting everything in. So, okay, so what we'll do is pause there, and then we'll see what we've got. So what we can do there is we can get all nice and close and personal with our colleague there. So you can see what we've done is all of our tracking alignment and all the features that we've picked up. We've picked all that up just purely from the texture and the colour itself. So if you're doing something, for instance, for a website and you want to have a 3D model available, it doesn't have to have moving parts, anything like that. This is great. So anything from a compressor, we go on Einscan's website, they've got a great example of some of the stuff that people have scanned. So we've got compressors, which are yellow, silver, and black. And no markers have been added to the surface. It's just done all from those three colours. That then can be all stitched together, hosted on a 3D website, and anybody buying any products can have an actual 3D model that can rotate and pan around. So if you want to put your colleagues on, you can do. So essentially there, what we can do, just like before, if we generate the PowerPoint data, we'll see how much of an accurate scan that we've got. So we've got a lot of PowerPoints in this one. So you'll see this probably going to take a little bit longer than it has done previously, purely because we've gone into detail and we're tracking the textures. So we've got all the textures then coming through on his face. So it's just going to mesh all those PowerPoints together for us. We'll see what we've got, and then you can see the kind of mesh that it's going to come out with afterwards. Now, there's things available for this particular feature. So in colour, there's colour printers available. Just could have his head printed in full colour. But again, it's very much 3D file hosting. One of the ideas that we're looking at here is virtual showrooms. So anybody with a product, especially with what's been going on quite recently for the last 12 months, very difficult for us all to get face-to-face, hence why we're doing everything from a distance. But it allows us then, if you have a showroom that you usually have people come to, you have a car dealership, and you're used to your customers coming in and being able to see things. Essentially what you could do with the scanner is you can scan all of those products. Then you can have a virtual showroom, and then anybody can come and visit in virtual reality, augmented reality, and then they can see the products themselves. Now, if you're a company which repairs a lot of things, scanning products will allow you to use augmented reality for repairs, for instance. Again, one of the things that we're looking into in terms of repairs on printers, for instance. We can have 3D scans of the printers available, and if you're doing a self-repair, for instance, we can actually show you a 3D model, which we've taken from a scan, and then we can point out all the features, anything that you would need to repair, and that could all come through Google Glass. So the actual possibilities of a scanner isn't just necessarily scanning an object and printing it. It's everything from file hosting to having virtual warehouses, showing off your products to anybody from around the world in meetings such as this. In the same way I get to show off a beautiful colleague, you can show off your beautiful, well-engineered products to people overseas, anywhere in the foreign markets, bits and pieces like that. So, yeah, possibilities are quite wide-ranging. So we squeeze as much into this seminar as we possibly can. And again, like I said at the beginning, if you do have any questions that are very individual to your business, your applications, by all means, just let Jordan know, and then we can always set up some one-to-ones. We can always email back and forth, and then if you want a one-to-one meeting, we can get that arranged. So as you can see there, the kind of detail that we've got through on Chris's face. The one thing that we have struggled on is just purely with the dark, shiny hair on the top. So we could stick with that, and we could adjust the brightness, we could go through. What I would normally do in this case is I would start to get rid of some of the ambient light around. So I would turn the lights down. I would get rid of some natural light, so it's normally go into another room. And then we've got a much better chance of getting that bounce of the light coming back from the hair and bits and pieces like that. You can see it started to come through. I've turned the brightness nearly all the way up. Once we get to that top end of brightness, if we're still struggling to pick the features up, all we do, swap location, we'll go into a darker office, and then we get the hair come through. So there we've gone through the HX and a lot of the features that it can do. Obviously, there's a lot of numbers involved in terms of how fast that it can actually scan, the amount of PowerPoints that it picks up. But I'm sure everybody interested has been on the website. You've had a look at the specs, hence why you're here. So that's it in practice. Like I say, from a applications engineering standpoint, typically time is one of my concerns. I have to get things done very, very quickly. And a lot of the time, scanning is a much faster option than me sat at my desk being paid by the directors to CAD that up, whereby it could potentially on one part take me an hour. With a scanner, as you can see, it can take anywhere from 5 minutes through to 20 minutes, half an hour, and I can pick up some really unique details. This, for instance, with Chris said, even on the scan, by having that color feature built into the model itself, just stops us from having to take pictures of Chris, JPEGs, go into CAD and then overlay them, which is, again, it's just workflow, and it just adds time into the workflow, and we all understand time is money. So everything built in there in terms of the features just gives you a much more closed workflow and allows you to get better results out at the end. Now, throughout the features and the ranges of the actual Einscan models, the HX is pretty much the newest top of the range. Anybody looking at any of the Pro 2s, for instance, Pro 2, yeah, Pro HDs, the accessories are really key. So you can get a lot of the features on the HX and the lower models. What you want to do is have a look at the core pack, for instance. If you have a look at the Pro HD, and this is the kind of scan that you're looking to do, essentially what you will be looking for is the core pack. But if you want to talk accessories, you want to talk about a different model that we've not gone over, by all means, let Jordan know. He'll connect us, and we can talk about that individually. So I'm hoping to cover as much as I can within the hour. If I just then share a quick another screen so I can just show you Einscan's website, and then you'll get a good idea of some of the other bits and pieces that you can do. And I'll show you.
I was going to say, Chris, while you're doing that, I was just going to quickly mention, if anyone does have any questions, I've dropped your email down below in the chat box. Obviously, you already have mine as well. And if you'd like a copy of this webinar for future reference, please do send me an email over and request that. I think a couple of the guys already have. So I'll send those over. So, yeah, no, thanks very much, Chris. It's been superb today.
That's the one I want. Okay, so whereas saying before is it's not necessarily limited to reverse engineering. Reverse engineering is a great feature. Like I say, that's my job. That's what I do all day, day in, day out. We've had a lot of requests recently because of everything being done at a distance. And you can scan objects and you can have a website, just like Einscan, whereby you can have the scan data and then that can be presented by Sketchfab. So if we hit play on that one, all that is essentially is the scan data and the information from the model itself. So if you're a wheel manufacturer, for instance, and somebody wants to have a look at buying a wheel from you, what we have is just a 2D JPEG. You probably have different viewpoints, where now in products, we can grab that and we can rotate it around and you can have a right good look at what people are going to get. So in terms of file sharing and file hosting for anybody who runs product websites, that's ideal. So essentially that can be taken. All you need is, instead of just hosting a JPEG on your website, for instance, you just need somebody like Sketchfab to be involved, which you can always speak to Einscan, connect anybody who needs to be connected. And essentially those files can be hosted on your website. So again, the sharing scan there. One of the ones that I like is one of the reverse engineering pieces. So essentially there, I think it's the end of gearbox casing. That's typically what I scan a lot, purely because, oh wow, it's come up with a car door instead of the gearbox casing. Wonderful. So with that scan there, you can see, for instance, the original CAD file, I'm sure is very, very confidential. And to reverse engineer such a thing would be incredibly difficult to do it via CAD. Not necessarily difficult in terms of drawing, but measuring and being accurate. Very, very difficult. Matching around verniers, essentially there I'd need a probe or something like that. Where with a scanner, everything's to scale, put that into CAD, we can tell it essentially to double check the scale, we can measure one particular point on the part. So 2 holes, for instance, we can measure the distance, how far apart they are, double check that, tell it this is the actual distance to a very specific point, and then scale the rest of the model to it. You can see there we've got full scale assemblies and bits and pieces. Now, one of the things I'll go over, and this is the more boring bit, is essentially the requirements that you'll also need if you have a scanner and you're looking to purchase a scanner. You just want your infrastructure to be able to cope and to be able to handle the amount of data that we're going to be looking at. So in terms of minimum, essentially in terms of what's required, you'll need at least 8 gig of memory. The USB ports have to be high-speed USB 3. A quadricard P1000 or higher, NVIDIA GTX 660 or higher, typically runs the scanners. My recommendation is to future-proof yourself and get as much processing power as you possibly can. Because essentially the more detailed scan that you want, the quicker it will be, and you'll have a much less processing time if we've got something that's up to scratch. So we've just done it again. We generally update our laptops as and when new scanners come out. so we can match our specifications to those. So in terms of the HX, because the amount of information, so we're scanning 1.2 million points pretty much every minute. That's a lot of data that we're transferring. So we need the USB 3. My recommendation is pretty much NVIDIA GTX 1080 or higher. Minimum video memory of about 4 gig. I'd say 8 gigs probably what I would recommend. And you want at least 32 gig of memory available. So as long as you've got all that, that's what we're working on here. So everything would operate exactly the same to the similar sort of speed and bits and pieces. So as long as everybody's got that as an underlying infrastructure, all the scanners are available. Just let us know. They're all variable to ship. Some of the models like Pro HD, for instance, we're looking at something like a 2-week lead time. Any others, let us know. We can tell you exactly what the lead time will be. A lot of them we can ship in 24 hours, bits and pieces like that. So just let us know. So if anybody's got any questions, we've got the chat box, and you can always throw that up there, and I can go through. If you've got anything that's particularly detailed, and like I say, you want to have a one-on-one session, just let Jordan know. He'll connect us, and we'll discuss all your particular needs. So I hope that was helpful for everybody. That's how I use the scanners on a daily basis. It's really been really quite helpful, going away from kind of vernier gauges and bits and pieces. I hope you get the same kind of abilities from it. For those who do CAD, if you want to know the kind of output formats that you can get, so OBJ, STL, ASCs, step files, 3MFs, P3s. So there's multiple file and outputs that you can get, depending on which software it is that you're using, SolidWorks, Fusion, Inventor, even some of the other kind of lower scale CAD models will all work. So it'd be interesting to hear what you guys want to use them for. I hope you've enjoyed it. Like I say, should speak soon to anybody else who needs any more information.
Brilliant. Thanks, Chris. You still hear me? My screen's frozen, so.
Okay, everything's running on here. I hope anything hasn't frozen for anybody else.
It's just mine, I think, for some reason. It's my Zoom because I'm recording it. But no, thanks for that, mate. That was brilliant.
So anybody, if anything's frozen at any point or any bits and pieces and you think you missed a key bit of information, let Jordan know. He'll send you the recording, or like I say, give me a phone.
Brilliant. Thanks, Chris.
Everybody.
Great work, mate. We'll see you later. Bye-bye.